That was sarcasm.
I know.
Okay. All right. What does it mean for two lines to be parallel? This is a question that you think, well, duh. What does it mean for two lines to be parallel? They taught me parallel in like what, third grade. I know parallel. What does it mean? Tell me.
Two lines that next to each other and never touch each other.
Two lines that never cross each other. Yep. Next to each other. Next to each other thing is interesting. I like that idea. Do they have to be like right next to each other? They could be far apart. As long as they don't touch each other. Is that a good definition for people? That probably was a good enough definition, and that's one most of us use when we were in, earlier grades. But the fact is now we do have three dimensions we're dealing with. And let's take for a minute, just imagine, take one of the lines going across the ceiling this way, okay? Pick any one of the seams in the ceiling, and that's our line. And then we got another line coming across the floor going this way. Those lines crossing the ceiling, that line crossing the ceiling and the line on the floor, do not touch each other, do they?
They're parallel.
And they never will. But are they parallel?
Oh, no.
One's going this way, one's coming this way. No, they aren't parallel, but they aren't intersecting either. So what are they? We got a special word for that. That's called skew. All right? Skew. S-K-E-W. That was one of our vocabulary last night. See, we have to narrow down and be a little more precise in our definition of parallel now, because we now have that possibility. We have two lines that don't touch each other, but they aren't parallel. So just not touching each other isn't enough. Not intersecting is not enough. They have to be in the same plane and not intersecting each other. That's what it means for two lines to be parallel now. So we're up in the ante a little bit. We're being a little more specific with our definition. And it's right here. Two lines are parallel if they lie in the same plane, or if they could lie in the same plane. Maybe that one isn't drawn in, but we could draw it in. And they do not intersect. Two lines are skew if they lie in different planes and do not intersect. Yes?
If those are parallel, they could intersect outside the plane, they could be parallel? As long as they don't intersect inside the plane?
Well, if they're in the plane, if the lines are in the plane, they don't leave the plane. Once you're in a plane, you can't leave the plane. You're thinking kind of four-dimensionally, which would be interesting. Yeah. No. Yeah. For what we're doing in here, the lines can't leave the plane. In order for lines to leave a plane, we need more dimensions than what we normally deal with in normal space and time. You're just thinking way out there, aren't you? That's good. I like that. I like that multidimensional thinking. That's excellent. So, yeah, for our purposes, if the lines are in the plane, they stay in the plane. They don't leave the plane once they're in the plane. So, let's look at this picture. Very typical type of question for a very basic level. I will name two lines, and you tell me, are they parallel, are they intersecting, or are they skew? They got to be one of the three. So let's start pretty simple here. Let's go with DC and AB. Would those be parallel, intersecting, and let's assume that each side of the box there is a rectangle. Those are parallel lines, yep. Because they're in the same plane, the top of the box, and they do not intersect. How about DC and GF? Skew. Okay? They're not going to intersect, are they? Now we have to imagine three dimensions here. So we got to imagine we're working in three dimensions. But they're not going to intersect, but they aren't parallel, so they're skew. How about GF and AD? Parallel. Why? Because we could draw in the plane, couldn't we? Okay. They don't lie in a plane that's drawn in that box, but we could create that plane that they both lie in, couldn't we? So those technically would be parallel lines. How about AD? Let's get rid of that. AD and DH. Obviously intersecting because they both go through point D, right? So you get the idea of parallel, skew, intersecting, the difference, because that's new. And again, on your note cards, you might want to even have a picture like this. I mean, you could have the definition parallel and skew, but you might want a picture on the back of, say, a box. Okay. And then highlight two sides of that box. And then that would be parallel. Or if you highlight differently, then you highlight for skew. So you got a little picture associated with the words. Use pictures with your note cards. We have a parallel and perpendicular postulate. We have what we're going to use is called the Euclidean parallel postulate, named after the ancient Greek mathematician Euclid from about 500 BC. So this is the thoughts that are 2,600 years old. Nothing new. You're not learning anything we haven't talked about. People haven't talked about since, heck, that's even before I was born. 500 BC. Just a little bit. But just, yeah. It's a little before I was born. It says this: if there is a line L and a point, I've named it P, not on that line, there is exactly one line through point P that is parallel to line L. That's a little bit confusing in words. But when we look at the picture, it's easier. I have a line, L, okay? There's line L. I have a point, P. P is not on the line. The question is, how many lines could I draw through point P so that it'd be parallel to L? One. I can only draw one. And the way I would indicate their parallels, I put these little arrows on the line that indicates their parallel. If I called this line, say, that was L, we'll call this one N, okay? I could say L is parallel to N. That's the symbol for parallel. So there's only one. I couldn't draw another line through P that would be parallel to L. I could draw skew lines, lots of skew ones, if I leave the plane. But I can only draw one parallel one. And also, I can only draw one that is perpendicular. And again, we indicate that with the little right angle box. Let's call this line K. And I would say L is perpendicular to K. So there's my symbol for it. And again, it's just one. Exactly one. One and no more than one. No less than one. One. That helps define the geometry we're working with. That's why we'll say we're studying Euclidean geometry in here, because we're basing it on the Euclidean parallel postulate. Everything's based off that. Basic idea. Everything we do the rest of the year is based off that idea. Are there other parallel postulates? You bet. Are there other types of geometry that could be studied when you get to college? Absolutely. If you want to mess with that idea and say there's at least one line through there, and you get multiple parallel lines through one point, it's mind-blown time, because it's hard to picture, because it's not the way we work with it, but you can do it. It's a whole new system of rules. But it's kind of interesting. This is where I want to get really today, though. The angle pairs. Because we've already dealt with some of these angle pairs, but now we have two intersections. And for those of you, most of you are in driver's ed or are going to be in driver's ed soon or are finished driver's ed already. We have two intersections here. Think of these as roads. I have two roads and a third road that crosses them both, creating two intersections. Now, for tomorrow, we're going to make sure the roads are parallel to each other. But for today, they don't have to be. Tomorrow they do. But for today they don't. When that happens, we call this line crossing the two lines a transversal. That's what that red line is called, a transversal. The area between the two lines is referred to as the interior. Obviously the area outside, therefore, would be the exterior. Outerior? Outerior? Okay. I think exterior, we'll stick with exterior for now. Outerior is an interesting word. I like creativity. So what we're going to do is we're going to start naming these different pairs of angles. Now, not every pair is going to have a name, but a lot of them are. Let's start with the ones we already know, linear pairs. Okay? There are 8 different sets of linear pairs in this picture. 8 different sets of linear pairs. 4 at each intersection. Somebody give me one set of linear pairs that you see. Just one. Okay, 5 and 6. And notice when I'm naming these, I'm using the angle symbol each time because I want to let people know I'm talking about angles. I'm not just putting 5 and 6 because that might be confusing. Angle 5, angle 6. Symbols. We've talked a lot about using the right symbol. So I'm doing that. I want you to do that too. What would be another pair? 7 and 8 would be another great pair. Another linear pair. Someone else. I want 8 people to answer this. 1 and 2. What else we got? That's 3 people down. 4 and 3. New people answering. What you got? No, because they're in a linear pair. Linear pairs have to be adjacent and supplementary. But 8 is with 7. What else would 8 be with? 6. There you go. Oh, I can't make a 6 today, apparently. Let's try that again. Ah, much better. Have you answered one yet?
No.
Okay.
1 and 4.
1 and 4. Yep. Didn't get that one yet. Getting harder now because we've used a lot of them up. 2 and 3. Haven't done those yet. One more set of linear pairs. Someone else hasn't answered yet. 5 and 7. Yes. That's the one we missed. Okay? So linear pairs, what do we notice about them? They're adjacent and supplementary. Both angles are always at the same intersection, aren't they? So I've got 8 sets of linear pairs. Fantastic. Vertical angles. We've done those before. These are not new. There are 4 sets of vertical angles in this picture. Again, like linear pairs, vertical angles, both are at the same intersection. What's one pair of vertical angles in this picture? 1 and 3. Yes. Another one. 6 and 7. Yes. Another one. 2 and 4. Excellent. I've got the same people answering all the time. I really like to get some new blood in here. Here's one more set. Come on, we can do it. It's from the lower intersection. 5 and 8. I know it's just... I know you know it. It's good. All right, those are the ones we already learned about. Fantastic. Now, these other pairs, we take one angle from each intersection. And they're a little bit different because the names are somewhat descriptive if we take the time to think about it. Corresponding angles are angles in the same corresponding position. So upper left goes with upper left, lower right goes with lower right, upper right goes with upper right, that sort of thing. So, just to give an example, upper left goes with upper left. So angle 1 and angle 5 would be a corresponding pair. What would be another corresponding pair? 2 and 6. Brittany, what do you got? 4 and 7. And therefore 3 and what? 8. Excellent. Those are corresponding angles. Alternate interior angles. Interior tells me that they're interior. Both angles are interior. Alternate means they're on alternate sides of the transversal. And they have to be one at each intersection. So, interior, let's pick an interior angle. 4 is interior. What would be alternate interior to that? 6, yeah. Alternate side of the transversal. 4 and 3 are already a linear pair, we know that. 4 and 5 are on the same side of the transversal. That doesn't help me. So it must be 4 and 6. What would be the other pair of alternate interiors? 5 and 3. Alternate exterior angles. Similar idea, except both are exterior angles. 8 and 1, excellent, good. And angle 7 and 2. Finally, consecutive interior angles, also referred to sometimes as same side interior angles. Interior, start with angle 4. I know 4 and 3 are what? What do we call that pair? Linear pair. 4 and 6 are alternate interior, so consecutive interior would have to be 4 and 5. They're on the same side of the transversal. And angle 3 and angle 6 are the other pair. So, how do we make these useful to us on note cards? Because we've got written descriptions, but how do we make it useful? What I would do is this. I would, on my note card, start by drawing a picture on one side. 2 lines and a transversal. And then I'd number my angles. 1 and 2. So it's the angle pair I want to work with. Because identification is such an important skill here, I need to be able to look at that and on the back of the note card write what the name of that angle pair is. So I can flashcard myself on that. What is that? Alternate exterior angles. Okay, and this alternate exterior is probably fine. It's my note card. Now, tomorrow we'll get a relationship to go with them. Either congruent or supplementary. We'll deal with that tomorrow. But that would be what I'd be looking for. Now, that to me is a useful note card, because you look at the picture, and you're going to have to do that a lot of times. You're going to have to look at the angle pair and be able to identify it. If all you have is words but no picture on your note card, it's really hard to do that. If you have a written description of alternate interior angles, again, probably not going to be the most useful, because you're not going to be given written descriptions. You'll be given a picture, and you'll need to have to identify them. So for stuff like this, that would be an ideal note card. How about this note card? Lines crossing. We'll make this angle 1 and that angle 2. What would that be? What would that angle pair be? Well, see, now that's what we want to. That's what we want to work on, to make sure that that's identifiable very quickly. Let's think about that angle pair. They aren't both on the interior. They aren't both on the exterior. One's on the exterior, one's on the interior. Yeah. Oh, you got the right starting letter. And again, we have so many C words here. It is a C word. Corresponding. Because they're both like upper right or top. Okay. If you consider these like 2 different X's, they're both the top of the X. So that's corresponding angles. See how we can make nice note cards for this? And do you understand how this could be really useful, is to look at the picture and then be able to identify it by name by looking at the picture? Because if you identify it by name, then we can probably figure out the relationship as well, because we'll get those relationships tomorrow. And that's what we're working on here, is identification. If you know what it's called and you know how it's related, you can do all the math in the world with it. It becomes very simple. If you don't know what it's called, if you can't identify it, it can be really hard to work with. You know what? I like to make sure I'm on top of my game, so I don't always draw my 2 lines the same way. But let's say I said angle 1 and angle 2 are there. They're both at the same intersection. That's okay. What do we call that pair? What? That's vertical angles, isn't it? That's our older one. And we know vertical angles are congruent. How about if I drew this one, angle 1 here and angle 2 here? Oh, this one's tricky, and I did that on purpose. No relationship. Okay? These are not corresponding angles. These are not alternate exterior. They are not alternate interior. They are not linear pair. They are not vertical. They are not consecutive interior. They are nothing. Some angle pairs have no relationship. So that was a tricky one. But that's going to happen. You're going to get angle pairs and say, they don't have a named relationship that I'm aware of. We could make one up, but it's not standard. So as you're doing your note cards, this is what you want to be doing. This is how you can quiz yourself on this stuff to make sure you learn these names. Because learning these names is really half the battle. And the relationships that go with them. Then setting up and solving problems. That's what we're doing. And again, I want your note cards to be useful for you. I don't want them to be just junk or just busy work. I want to be something that you can go back and use to help yourself study for tests and review and go over things. All right? And pictures are going to help. Pictures are huge. It's geometry. Yay, we get to draw things. For those of you who are more artistic, this should be really nice. Got it? All right. Any questions on that stuff? Primarily what we're doing is identification and answering a few questions about parallel. It's section 1 of the chapter, so it's very much vocabulary-driven identification. What is it? What is it? What is it? Tomorrow we'll talk about the relationships for these angles, and we'll review for half the period on Friday and take the quiz the other half the period. We'll finish the period with a quiz on Friday. We'll use the first half for reviewing. Yes? That's the benchmark on Friday, yes. And then next week we review Monday and Tuesday and take our unit test on Wednesday. Okay? Please, if you still have things sitting out there, get them taken care of as far as old benchmarks.